Hi everyone, my name is Juliana Porras and I did my research under Dr. Colleen C. Naughton at the University of California, Merced. My research analyzes the impact of COVID 19 on air pollution in both rural and urban California. I want to talk about the shelter in place orders that were enacted globally. It did reduce air pollution, and I want to focus your attention on the region of China, more specifically because it is a heavily polluted region and it was one of the first countries to go on lockdown. And so, as we focus on image A right here on the left, you'll see the reduction or the response, I shall say, to the shelter or lockdown um, enacted. And so here you can see that the most negative change um, is showing by the blue coloring. And so here we see that there's a lot more negative reduction, and here not so much. But then as we focus our attention more on the right image, image B, we see the PM 2.5 response, and here you see a lot more reduction taking place. That does show a lot more changes. And so this is motivation to my research, as it had me questioning whether California had either the same impact or what the shelter in place orders, how that impacted the state of California. So, as we know, the shelter in place orders were enacted March 19th, 2020. So, my focus is on secondary air pollutants like ground level ozone and particulate matter 2.5. I want to focus in on these pollutants because they are known to be one of the most hazardous to human health. And so, for ground level ozone, it can lead to respiratory illnesses, and people can experience symptoms like inflamed throats, coughs, chest tightness, and also it can worsen asthma. And so my focus is primarily going to be on the San Joaquin Valley. As we know, it does have some of the worst in the nation. And so some of the primary sources of PM 2.5 are car and truck emissions, which takes up about 50%. And then there are natural sources like wood smoke and dust, which is the other 50%. And so I want to draw your attention to figure two over here on the right. And so if you're not familiar with the state of California, it's pretty big. So the San Joaquin Valley is where I'm going to be focusing my research on, and I'm going to be comparing this rural area to the San Francisco Bay Area, which is heavily urbanized, and then South Coast Air Basin, known to be part of the LA County, Riverside County, but mainly LA County, and then the Sacramento Valley, which is about 95% rural. So here we have the rural cities, and then here we have the urban, which I'll be comparing. Um, and so, some of the research questions that I would like to address, well, one is were PM 2.5 and O3 concentration levels significantly different after the COVID 19 stay at home orders that were enacted in California? And then, what are air quality differences between both rural and urban areas in California as a result from the COVID 19 stay at home orders? Our studio was used for taking the statistical analysis. And so what I did was I downloaded the data from the California Air Resources Board, and I was able to take the averages of those months. So then I have the months from January all the way to June for each year, and so it's important to know that I only took it for those first 6 months of the year. And then I also created the ozone and particulate matter plots that you'll be seeing in the following slides. So overall, my null hypothesis for the R code was no statistical significance in ground level ozone and PM 2.5 changes between the past years, which are 2017, 2018, and 2019, and then the present years, which is 2020, in rural and urban California. So I want to show you a little bit of my results. So here is the San Joaquin Valley Air Basin, and keep in mind that the particulate matter 2.5 is measured in micrograms per meters cubed. And so here we have like a linear slope here going down. And so it kind of just shows you like, yes, there's a reduction as you see that the mean or the average is 17.53 for 2017. And then it's going down until 2020, you see it's 10.07. And then as we compare it to the South Coast Air Basin, you also see it is going down as well. And then for the Sacramento Valley Air Basin, it does go down too. And then the San Francisco Bay Area Basin, it does go down. As you can see, the mean average here is 10.34, and then it goes all the way to 8.06. As for the ground level ozone, ppm does go down, but not as greatly. So we see 0.035, and then we see a 0.0399, and then we have a 0.0412, and then we have 0.0383. And so you do see it like going down, but not as great. And then as we compare that to the other basins, we do see that there is also like a reduction, but not as great. And I think that's important to recognize because as I showed you in the other graph for particulate matter 2.5, you do see that there's more of a linear trend um, as a result of the lock-in orders. And then a few results that I found were that ground level ozone and particulate matter 2.5, their concentration levels did show to have like decreases in the rural San Joaquin Valley, as I showed you previously, but not as drastically as I hypothesized. So originally, I was seeing pictures from NASA released showing regions in China, they're having clear skies. So initially, I had thought or concluded that yes, there was going to be a lot more reduction, but as I showed you before, not so much. And then we see that cities located in the Sacramento Valley, which is 85% rural, they did have the greatest significant changes or impact, where we see that the P is less than 0.01 for March and April specifically. And so down here is a little snippet of my R code results, and you can see that the P value here is 4.553 times 10 to the negative 11, which is way smaller than 0.01. So my conclusions are that the response to the COVID-19 shelter-at-home order, it did lead to many cars off the road. So as a result, you did see significant changes in the secondary pollutant emissions. However, we were still seeing toilet paper in our stores. We were still seeing essential workers still commuting to work. So that could result in why my reductions weren't as great as hypothesized. And then in rural and urban California, so we did see subtle changes between the two. I think it is also important to note that they are dependent on the region and it is also dependent on the pollutant. So as you see, or as I've showed you for particulate matter 2.5, the trends across the basins, whether rural and urban, they did go down ultimately, and it was linear as I had shown you. However, for ground level ozone, the it wasn't as patternized. There wasn't a clear line showing that there was a huge reduction, and so it is important to recognize that different pollutants have different sources. It is important to include meteorological factors like climate, temperature, precipitation, humidity. These all play a huge role in how pollutants are suspended in the air. I would like to thank NSF Camp for funding my research this past summer through fall 2020, and I would also like to thank my PI, Dr. Colin C. Naughton at UC Merced, for all the help and advice on my research. And here are my references, and this concludes my presentation. Thank you.